This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Everyone okay? So I'm going to do a brief presentation on an issue for M6 Junction 3. It's about some strategies that was developed in preparation for the 2022 Commonwealth Games. Bit of background. So it's a five-armed roundabout. You can see it at the top of there. It's got the M6 eastbound and westbound off slips. It's also got the A444 north and southbound, and then it's also got an unsignalised approach on Pickard's Way. Warwickshire County Council was the client, and they're responsible for the maintenance and operation for the site. The site is connected to their UTMC system, which in this instance tends to be a Yunex Traffic system. So it's connected to their strategy manager and UTC UX. Site is in close proximity to the CBS arena, formerly known as Rico, which is just south near the Rowley's Green roundabout. That happens to be in a different local authority now. That's on Coventry's network. Due to CBS arena, it hosts, in addition to sporting events, it holds nighttime events, music concerts, etc. So that can lead to sudden surges in demand on the network. There are pedestrian facilities across the A444, but when there's large events on, due to anti-terror policy, they can close the A444, which can lead to additional congestion, both north of the A444, M6 Junction 3 and southbound on the Coventry network. The other added complication is you can get motorway closures, again, which tends to saturate the motorway roundabout. The site, in this instance, works scoot control with a CLF backup. At the onset of congestion, all the drivers tend to compete for the available road space on the roundabout, which can result in occasions in locking up. Once this happens, it can take in excess of 30 minutes to start to clear. There have been previous attempts to develop strategies for this junction. It was with limited success, and as a result, these were, rather than being automated strategies, they were reserved for manual intervention by operators, the UTC station. The reason for the limited success is they fired commands to the UTC system, so you'd often get competing demands. So you get an issue on the motorway offset, or put a demand in, fire a command to UTC to develop a plan. Then you get the roundabout, do the same thing, and it could flip-flop between the two. So it wasn't particularly stable. As I said, as a result, the strategies was developed, resorted just to that manual operation. So Warwickshire approached us and asked us if we could develop an automated strategy. So all the previous strategies had individual strategies for each approach. So you'd have an approach strategy for the one off slip, one for the other off slip, and then one for the northbound. And so all these were separate strategies which competed against each other. So Warwickshire asked us to approach us and asked us to develop an automated strategy encompassing all those strategies into one super strategy, so the competing needs. So as I said, it's a motorway roundabout operating scoot. In this instance, in addition to this conventional scoot detectors, there's also queue detectors on the back of all the circulators. There's also some on the towards the rear of both motorway off slips. Site is controlled by two 950 controllers, each operating two streams, and each having two-stage, two-phase, fairly simple approach. For the purpose of this, the queue detectors have been set up on the UTC database, so any queue time is set up on the OTU, and that reports back onto UTC. So the other remit that I wanted with the strategy development was to try and, if possible, keep the method of control scoot to avoid flipping between different modes of control and the constant recovery process. There's also a physical link between the two controllers, just to provide some sort of means of backup if there's a loss of comms or faults and the UTC is not operational. The site has no pedestrian facilities. As I mentioned, this is scoot control, but it could equally apply to mover, VA, things like that. You could apply the same principles to help ease congestion. So that's the scoot arrangement. So all the links, all the different nodes, and then obviously we've got the queue detectors on there as well. So one at the back of each of the circulatory links. This was the baseline scoot data. So it speaks for itself. There's only those 4 nodes in the region, and that's all the relevant data for the 4 nodes. As I mentioned before, all the strategies had all the approaches had individual strategies. We encompassed all those into one single strategy with a hierarchy as there. So the circulators had the highest priority, so any queues on the circulatory, that was deemed highest, followed by the M6 westbound off slip, then the A444 northbound. Historically, on the A444 southbound, there's no issues, and if there is an issue, the local authority deemed that's the most appropriate place to store any queuing vehicles. So how do we detect the queues on circulatory? So we have, as I mentioned, queue detectors on each of the circulatory links. To avoid it being oversensitive, you can see that a minimum of 2 of the circulatories need to be activated, or queue detectors to activate that strategy for the clearance. So on the, you can see there, for the top one, the southbound circulatory, there's 3 loops on there. It needs 2 of those to be activated to generate demand for that circulatory link. The eastbound circulatory has 2, it needs both. The queue detector on the eastbound circulatory, it says minimum of 2, or said that there are only 2 detectors on that approach, so that's the same thing. And then likewise, all the detectors on the other approach. So minimum of those 2 will activate the strategy to clear the circulatory queuing. Once it's been detected, what's the mechanism for clearing it? So we've used the congestion as measured on the circulatory links. So the congestion on all the circulatory links needs to be clear. We've also put a time factor on there. So all the congestion needs to be cleared for a minimum of 2 minutes before it'll go back to the default stage, normal operation. So again, the 2-minute threshold is just to make sure it's not oversensitive and flipping between the 2 states. The M6 westbound off slip, Has 2 tiers of triggered section. So the first, less aggressive, is the detection of on-slip, detection of congestion on the on-slip. That's as measured in the Scoop model. So the less aggressive one is the top one on the screen. So if congestion on the approach, link B in this instance, goes above 5, it will trigger it on the proviso or condition that there's no congestion on the internal circulatory link. Also, there's a queue detector that needs to be inactive. If that doesn't assist in easing the situation and the traffic does back up to the queue loop, then that activates a more aggressive strategy where it gives it more green time to help flush the traffic out. So once it's been activated, what's the mechanisms for clearing that? So we've got the normal mechanism, so the congestion has to drop below a certain threshold. Again, it has a time frame on there, but equally, if we activate the queue detection on the off-slip, and then all of a sudden you get a demand on the circulatory, we need that circulatory link with a higher priority to clear or turn the strategy back into default so it can deal with the circulatory link, which is deemed the more important link to clear. So what did the strategy, this is what the final strategy look like. So the circulatory ones at the top, the westbound off-slip, as I said, had 2 tiers of response to congestion, and then the the 8444 had 2 levels of response. There's one for the daytime, and also there's one for the night time for the events at the CBS arena. So what those strategies do, once they're activated, they action casts within UTC. So they're all the casts associated that was developed. So if you get a queue on circulatory, for example, cast 209 is actioned on the UTC database. Then once it starts to ease, it'll go into cast 213, and then when it clears, 2110. So they're all the casts associated with the strategy. What does a cast do? In this instance, they change some of the Scoop parameters. So if we can see the top one, cast 209, that basically puts all the approaches to a minimum green time. So 7 seconds green, or start 14 seconds, 7 seconds minimum green, 7 seconds into green. If it starts to ease, you see there the queue reducing, it increases that stage min to 20 seconds, so it gives it an extra 7 seconds on the approach. So it allows the circulatory to move, allows a bit more traffic onto the approaches to try and reduce any congestion. Once it's cleared, it'll then go back into the default stage, which is cast 220. So again, it's just manipulating Scoop data to control the timings. This is an example of it running. So the top element of the screen is the strategy manager. So I think this is for the 30th of July. You can see what came in. And then at the bottom of the screen, you can see the UTC log, what's been actioned. So in terms of additional work we could do to improve it, obviously I mentioned this one is in Warwickshire's local authority. Collaborative traffic management, so as the name suggests, allows multiple local authorities to provide a coordinated approach to dealing with transport issues, so a proactive rather than a reactive response. So in this scenario, M6 Junction 3, we could have inputs from the commentary system which pre-warns M6 Junction 3 there's issues about to come and we can deal with it more effectively. So likewise, it could be linked up to the national highway system. So anything on the motorway, again, could feed into the strategy. in summary, say that the client said that the key point of the project is that automation. They didn't have the resource and the budgets available to continue manually operating it. So since it's been implemented, there's been no manual interventions. That was a short and sweet. Appreciate some of the content was a bit technical, but it does bring it to the end of the presentation. Any questions?
We have one question for Nick, just over. Oh,
Mark Bladel, PTC. Thank you, Nick. Before and after data, do you have any? How well did it work?
They've measured it on, because the congestion, once it's saturated, the data will be available on UTC. So we put the strategy together. So the feedback we've had from Dave Mosson at Warwickshire is basically that there's been no manual intervention required since it was implemented.
Yeah.
But yes, I've not crunched actual numbers though, but it should be there available.
Okay, thank you.
do we have any more questions for Nick? No?
That's all
Nick,
right then.
thank you very, very much for your presentation.
Thank you very much.
Thank you.